Okay, so now that we've kind of explained what the high level meaning and definition of logistic regression is, now we need to talk a little bit about metrics because you don't know how good your model is unless if you can evaluate it. Most of these you don't need to worry about too much. Specificity and sensitivity are similar to precision and recall in that they're also inversely related. So in order to get the best results, you want to adjust your threshold that I previously talked about. And then the other thing that you want to pay attention to here is accuracy, which is just the number of true predictions over the total number of predictions. And then let's look a little bit more at the confusion matrix in the center, because that's where we get all of our numbers from which we can calculate all these other metrics that you see on the right and the left. So in the confusion matrix, in the upper right hand corner, it'll list the number of true positives. In the upper right hand corner, it'll list the number of false positives, and in the lower left-hand corner, I'll list the number of false negatives, lower right-hand corner, number of true negatives. And so using those numbers, like I said, we can calculate all these other metrics using these equations right here. Okay, so when it comes to logistic regression, another evaluation metric that people like to use is ROC and AUC. So the ROC curve, which stands for the receiver operating characteristic curve, is really just the true positive rate over the false positive rate. And then the AUC is just the area under the curve. And so what you want is for the area under the ROC curve to be as close to 1 as possible, because that means that your true positive rate is really high. And then some people also like to use log loss to evaluate their logistic regression function. Log loss uses linear algebra once again, so I'm not really going to go deep into how it works. But essentially what you need to know is that when it comes to log loss or any loss function, you want to minimize it. And so the closer your log loss is to 0, the better. Great. So now we're going to see if we can create a logistic regression model in Python. You can use whatever environment you so choose, but today I'm going to be demonstrating logistic regression very simply, just in Jupyter Notebook. And so let's get started. So I'm going to import pandas. You can also import Seaborn, Matplotlib, and other things if you want to do data visualization and things like that. But today, because it's such a simple problem, I'm not going to do that. We are going to be working with the breast cancer dataset from scikit-learn. And so the problem for today is a binary classification problem in which you're trying to determine whether a person has breast cancer or not, or predict that based off of some data that you're going to feed to your model. And so what I'm doing right here is converting the data that you get off of scikit-learn into a pandas data frame, because unfortunately when you download it from scikit-learn, it doesn't come as a data frame in pandas, and so you have to convert it, making sure to add that target variable on there as well. And then let's check to see if everything went smoothly. Great. So we've just converted the breast cancer data set into a pandas data frame. And here you can see we have a ton of features. We have 29 features because we're excluding the target column. And so that's a lot of things we can predict off of. Now there's something in classification called the rule of 10 that says that you should at least have 10 times the number of samples as you have features. And so in this case, we have 569 entries or samples, and so that's more than 10 times 29, and so we are good. Now the rule of 10 isn't a hard rule, but just know that it's there to avoid overfitting. Okay, so let's just briefly check out how balanced our data is. So as you can see, 357 of our samples are in the 1 label, and then 212 have the 0 label. And so it's not 50-50 perfectly, but it's pretty close. I mean, you could balance it a little further, but for the sake of this video, this is good enough. With 357 of our samples have breast cancer, and then 212 don't have breast cancer, because in binary classification, 0 stands for false, and then 1 stands for true. So let's go ahead and assign our x variable and y variable. So our x is going to be all of our features, and then our y is going to be the target or response variable, whether or not they have breast cancer. And then let's go ahead and split those data, this data set into a training set and a testing set. So we're going to split our x and y into x train, x test, and y train, y test, using train test split that we can import right from scikit-learn. The amount of data that is going to be used in our test sets is 30% of the total amount of data, and then 70% of the data is going to go into our training data. So we have more data used for training than we do to test our model at the end. So let's go ahead and train our model. So we're going to import Logistic Regression. This is a Logistic Regression model. Set the max iter a little bit high because we have a lot of features, a lot of entries. And then let's go ahead, boom, train our model. And while we're at it, we can do this all in one kernel. Once our model has been trained on the training data, then let's have our model make some predictions on our test data. So let's see if that worked. Perfect. And then we can evaluate our model, see how accurate it was, and check other metrics as well. Essentially comparing how different our model's predictions were from the actual labels for the test samples. Let's go ahead and print out these metrics. Awesome, okay. So it looks like the accuracy of our model is 94%, which is really good. As you can see, our confusion matrix also shows that in the test data, in general, had more negatives than we did positives. And so that can also have an influence on how our model did. Below we have our classification report with precision, recall. Once again, we have accuracy, this time just rounded to 2 decimal places. Also our F1 score and support. And so these are all great metrics you can use to evaluate your model. Overall, our model looks pretty good. Thank you guys so much for watching this video. If you liked it, please hit the thumbs up and subscribe to our YouTube channel. Don't forget to check out our social media at Student Machine Learning Coalition, and we'll catch you next time at our next video on KNN.